Hi, today we'll be looking at problem 974 on LeetCode, which is subarray sums divisible by k. So if you look at the question closely, it says that given an array of integers, return the number of subarrays that have a sum divisible by k, which means that given a particular array, we need to return the number of arrays that are continuous, subarrays that are continuous, that are divisible by k. So let's look at an example to make sure that we understand the problem. Given this array, we have k is equal to 5, the output should be 7. And the reason why is because there are 7 subarrays within that array itself, whose sum would be equal, would be divisible by 5. So if you look at all of the examples in this case, so it's 4, 5, 0, minus 2, minus 3, this cancels itself out. And then you have 4 and 1, which is 5, which is divisible by 5, so that's 1. 5 divisible 5, 5 plus 0, same thing. 5, 0, minus 2, minus 3 adds up to 0. Divisible by 5, 0 by itself, 0 and minus 2 and minus 3 adds up to 0 again, divisible by 5. The same thing here. So there are 7 subarrays that would add up to 5. So the question does take a little time to understand, but it's not too hard. So let's look at the approach that we'll be taking in this problem. So our approach will be to initialize an array of size k and keep a track of the number of times that we see a particular remainder. And the way we do that is obviously by using the modulus operator, and the modulus operator, it would give a number only between 0 and k minus 1. So that's the reason why we are initializing an array of size k. So let's run through an example and see why the method that I'm actually proposing works. So we initialize an array of size k, and we have everything as 1. But array, this remainder array will have the base case of the remainder being 0 is 1. And then we have two other arrays. We have two other variables that would keep a track of the current running sum, and then the count of the number of arrays that we've seen so far that are divisible by 5. So let's get started. So we start with 4. And then we just add that to the sum, and every time you add a particular number to a sum, we make sure we mod it, and we try to see if we have seen that modulus, we have seen that remainder before. So we see the sum is 4 so far, and then we come here to the 4th place in the array, so 0, 1, 2, 3, 4. We haven't seen it before, so you don't do anything with the count, but after you've checked if the count has to be incremented, it doesn't have to be incremented, so you initialize the number of times you have seen 4 as 1. And then you come to 5. 5 plus 4 is equal to 9, but you mod that, and then the sum is 9, but you mod that and it becomes 4. You check if 4 has been seen before. We see that it has been, so we increment the number of times we have actually seen that before to the counter, and then we increment the place with the 1, which is 2. So that basically means the reason why this particular method works is because if you see a mod in the current place and you've actually seen that before, it means that anything between those two places, your sum would equal to 0, and that is divisible by k always, because since x minus x is always equal to 0, so anything between that will give you 0, which is divisible by k. And the number of times you have actually seen that before, that would be the number of sub-arrays that could actually be divisible by k. Let me know if that wasn't very clear in the comments, but I hope that's intuitive enough for all of you. So where were we? So we finished 4 and 5, and then we come to 0, and then we have sum as 4, and we add 0 to that, it still remains the same. We come here and check that we actually have seen 4 twice before, so we increment the count by the number of times we've seen that before, so this becomes 3, and then we increment this by 1. Yeah, so this becomes 3. And we come to minus 2. 4 minus 2, this becomes 2. We haven't seen 2 before, so you don't do anything with the counter, and you just increment the times you've actually seen that 2 to 1, excuse me. And then you have minus 3. Since 2 minus 3 will actually give us minus 1, you need to, anytime the sum is minus 1, you just add k to that. So this, in this case, it would be -1 plus 5. So this becomes 4. And we see that we actually have seen 4 before. So we add that counter again. So that becomes what? 3 plus 3, 6. And we increment this by 1. And then we come here and we see that the last digit that we have is 1, and you add 1 to that, it becomes 5, and then you mod it to get 0. And we go to the 0th place, which is 1. You add that to the counter and increment that, but you don't really do anything right after. So this will be the last state of your sum, your count, and your remainder array, and you just return the count. If this seems a little tough to you, work through an example yourself and try to understand why this works. But I hope this explanation was clear enough. Let's code this up. We already have the remainder array, and we have initialized base case. So we would initialize 2 other variables, sum, the running sum, and then we have the count, which is equal to 0. In the end, you're just returning the count. And then you have a for loop for a in, let's say, a. Yeah, so sum is equal to sum plus a. Yeah, you're adding the current element, and then you're doing a mod by k. And just to make sure that we're covering the case, you also want to check if it is less than 0, you would want to add that sum plus equals k. Here, right? So in this case, you would say count plus equals to remainder array of sum, and then after you've added all of that, you want to increment it by 1. So this right here, Control-C. Yeah, so that makes sense. We've covered all of our cases. Let's do a test run. This seems okay. We'll do a submit. Cool. So that works. Yeah, so let me know if you have any questions in the comments below, and don't forget to like and share and subscribe.